Hello everyone, and welcome to your section 1.4 notes. Today we'll be talking about the properties of real numbers, and by the end of the day, students will be able to identify and use properties of real numbers. To get us started in the lesson, go ahead and look at these four statements and complete them with an equals or with a not equals. Okay. So the first one is equal, the second one is not, the third one is equal, and the last one, not equal. If you want a further in-depth explanation, go ahead and find the examples explained video on Schoology. Let's jump right in. So we say that two expressions are equivalent expressions. I should probably form a Q correctly. Equivalent if they have the same value for all values of the If they have the same value for all values of the variables. So that means they're always equal all the time. For example, here, a plus 12 is always equal to 12 plus a all the time, no matter what a is. If a is 0, 0 plus 12 is equal to 12 plus 0. That's 12 on both sides. Or 100 plus 12 is also equal to 12 plus 100. It's 112 on both sides. This will always be true. Similarly, in B, no matter what P is, this will always be true because 4 minus 4 is 0, and anything times 0 is always 0. And finally, this will always be true because here we say our x's reduce, and then the 12 reduces to a 6, and the 2 reduces to a 1, so 6 times y is equal to 6 times y. We say these are equivalent because they are always equal. Okay, so here we go. Let's look at some properties of real numbers, and for some reason on my notes, the title didn't come in, so let's write that in real quick. Properties of real numbers. All right. So the first property we're going to talk about is called the commutative property. Now this morning on my way to work, I commute to work. I say I have a 22-minute commute because that's how long it takes for me to get to work. And what commute means, it means it moves, right? You can arrange them. You can move. So what this means is that, so the technical term says, changing the order of the addends does not change the sum, and changing the order of factors doesn't change the product. What that means is if we add two things together, those are called addends. If we change those around, we say b plus a instead of a plus b, that's still the same thing. For example, if we have, 18 plus 54, that's equal to 54 plus 18. That's fine, that will always be true. Okay? So it works in adding, it also works in multiplying. So we can say a times b is equal to b times a. So if we had like 12 times 1/2, that will always be equal to 1/2 times 12. Because it's 6. Yay, nice. Okay. So commutative means you can move the numbers around and that doesn't change the sum or the product. Our next property that we'll talk about is the associative property of addition and of multiplication. What the associative property means, it means they can associate, like if you go on a social media or you have your associates, these are people that you are friends with, that you know, that you are grouped with. So grouping numbers doesn't change it. So we say changing the grouping of addends doesn't change the sum. That means when you add numbers, like if you add A plus B together first and then add C, that's the same thing as adding B plus C first and then adding A. So for example, if I wanted to do, if I had 23 plus 8 plus 2, that's the same thing as 23 plus 8 plus 2, but I do the 8 plus 2 first. And this one would come in handy because 8 plus 2 is 10, and it's a lot easier to do 23 plus 10 is 33 than 23 plus 8. Okay, that's 3 plus 8 is 11, so 31, and 31 plus 2, that's 33. So the associative I use the associative property a lot, actually. So there you go. And then finally, with the multiplication, so changing grouping of factors, when you times numbers together, that doesn't change either. So you could do A times B times C first, but that's the same thing as doing A times B times C. That doesn't matter. So like we could do 7 times 9, for example, times 10 is equal to 7 times, but we do 9 times 10 first. Like maybe you find it easier to do 90 times 7 is 630 than 63 times 10 is 630. In this case, actually, I think the first one's easier, but that's up to you. So we talked about commutative, which is moving, associative, which is grouping. I almost had to sneeze and then I didn't, so that's fun. And then our, to round out these three guys, I'll get a new kind of green. We have the identity property. Identity. Your identity is who you are. That's how you identify. And that's key to who you are. So we say for addition, the sum, which is adding, of any real number and 0 is the original number. That means if we have any number and we add 0 to it, it's still that number. You add nothing to it. Like, 8 plus 0. 8. Cool. And then the product, which is multiplying, of any real number and 1 is the original number. So if we have any number A times 1, that will always be A. So we had negative 22 times 1, that's still negative 22. That number does not change. It's identity. It's like looking in a mirror. Awesome. Now we have two special multiplication properties that we'll go over real quick. And this is only true for multiplication. It doesn't work for addition. We have the 0 property of multiplication, which just says the product of A and 0 is 0. That is any number A times 0 will always be 0. When you multiply any number times 0, you're going to get 0. So like 18 times 0, 0. Then you have the multiplication property of -1, which says whenever you multiply any number by -1, any number times -1 is going to be that number, but negative. So we'll do two examples. Like 4 times -1 is -4, and then -3 times -1 is -3, which is a +3. So we can just get rid of those. Cool. So those are our 5 properties that are a key idea of the day. Commutative is moving, associative is grouping your friends, identity is maintaining who you are, and then 0 property is you're always getting 0, and then -1 is you getting the negative of that number. Let's go ahead and look at an example 1. Tell me what property is being illustrated by each statement. Pause the video and label each property. Okay, so for this first one, that is the 0, I'm going to abbreviate, property of multiplication. B, we have the associative property of addition. And then finally for C, we have the identity property of addition. Okay. Now, this is all great and fine and dandy, but when are we going to use this in real life? Well, I'm so glad you asked. So let's say we have Antonio, and he wants to go see a movie. So in order, I'm going to buy a ticket first, and the ticket costs $7.75. That's a cheap ticket. It must be on sale or something. And then a drink costs 240 cents, which is $2.40. And then finally, popcorn costs $1.25. What is the total cost? Well, we could go through and we could add them up with a calculator, but then you have to find where your phone is. So instead, I am going to use the I'm going to use the commutative property to rearrange them. I'm going to move these two around. And what that will look like is I literally move them. I can commute. It goes on a commute to work and says, hey, I'm going to go over here to rearrange that order. And now I will add these two first. I did that because you have the 75 and the 25 is going to come out real nice. That gives us a solid 9.00 plus 240, which is 1140. There you go. Awesome. Okay, now you're going to use your properties to simplify each expression. Go ahead and pause the video and unpause when you think you have the answer. This first one comes out to 15n. B is 7b plus 12. And finally, C is 6x. If you need further explanation, watch the extra explanations video. Okay, we have two more definitions for you. One more example, and then we're going to do our homework. Okay. So we're going to talk about reasoning. Reasoning just means like thinking. It's a way to think, like giving your reasons for something. And we have a certain kind of reasoning, which is called deductive reasoning. That's when you deduce something. I know that's not helpful, is it? But what happens is you start with given facts, you start with information, and then you can make one conclusion based off of that information. For example, if we know that good students are rewarded with candy, and Cash is a good student, then Cash is going to get candy because he's a good student and good students get candy. So that's an example of deductive reasoning. One of my favorite things on this whole earth is called a counterexample. Counterexample is, ready? An example that counters an argument. Man, these are great definitions. To counter means to go against or to break something. Like counterclockwise is to go the opposite way from clockwise. So a counterexample, that is one word, by the way. It's not like an example of the counters in your kitchen. Counterexample is one word. It's an example that shows a statement is false, that it's not true. And guys, guess how many counterexamples you need to show that a statement is false? You only need one counterexample. So for example, I have the statement, all math teachers are men. And I can prove that wrong with one counterexample. Me, I'm not a man, and I'm a math teacher. Boom. Or I could say, well, Miss Shibley, she's not a man, and Miss Young, she's not a man either. I could also say all prime numbers are even, but then have a counterexample for that with 2. 2 is, it should say all prime numbers are odd. Okay, but anyway, so if we have this statement, all prime numbers are even, our counterexample is not 2, the counterexample is 3. because 3 is a prime number and 3 is not even. So there you go. That was my bad. And then finally, if I have this statement A minus B is the same thing as B minus A, I say, well, that's not true if A is 4 and B is 3, because then that would say, well, 4, here, I'll write this in orange. 4 minus 3 is not equal to 3 minus 4, because 4 minus 3 is 1, and 3 minus 4 is negative 1, and those are not the same thing. So you have it. A counterexample proves that it's false. So for our last example, I want you to determine if each of these statements is true or false. Go ahead and pause the video. If it's false, give a counterexample, and then when you have your answers, play the video to check your work. Okay, A is false. B is true. And C is true. Got it? If you want further explanation, go ahead and watch the extra explanation video, and then summarize for me the most important thing from this lesson, a question you have or something you wonder about, and then make up a quiz question, and remember to include the answer. Have a wonderful time on your homework, and have a great day.